as co-workers. I'm happy to see you all, and we'll try to keep you awake after this post-lunch session to be involved with me in this talk on the healthcare innovations which we had in our institute. As introduced, I am from a public sector undertaking under the Ministry of Health and Family Welfare, HLL Lifecare Limited, which was previously known as Hindustan Latex Limited. So we are engaged in the healthcare innovations, supporting the ministry for the national family health programs, which includes supply of contraceptives, hospital products, nutraceuticals, personal care products, diagnostic services, retail pharmacy, and projects are the few areas where we serve the country. So our punchline of action is to innovate for healthy generations for the government of India and also for the rest of the world. Not working. Okay. 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 Thank you. So I'm happy to be with you this day for sharing my experiences in the journey towards innovating for healthy generations. This will be my contents of my talk. I will be talking about my institution, HLL Lifecare Limited. I will be speaking on latex technology into some detail, which will enlighten you about the science and technology behind the products which you see. Our products which we have derived from latex in the company, and a small wrap up of the introducing AI in latex rubber technology, and a small conclusion. As I told HLL, we are celebrating our 60th year of formation, the Diamond Jubilee. We have presence of manufacturing sites and marketing all over India and a global reach in 45 countries. And we supply our products to major procurement agencies in and around the world. Our purpose is to provide quality healthcare and product services at affordable price. So from the formation till now, what is HLL? We started with the family planning program requirement of production of condoms. Later, we diversified into other medical devices, other contraceptives, which are implants and injectables. And then we diversified into medical devices, which includes blood collection bags, hydrocephalus shunt, tissue expanders, surgical sutures, and so on. And we are into services since 2000s. We are into services. We are having the chain of life care centers and Amrit pharmacies all over the countries to provide affordable pharmaceutical products and implants at affordable rates to the population. So as a business overview, we are into three different segments. In contraceptives, pharma and FMCG. We produce condoms, intrauterine devices, oral contraceptive pills, hormonal pills, and personal hygiene products, which include sanitary napkins. Hospital products, which includes blood bags, surgical sutures, disinfectants, and rapid test kits for various infections. And healthcare services, we have the umbrella of Hind Labs, which is a pathology labs, which is seated in all different parts of the country for providing testing of all parameters at affordable rates. We are having Hind Labs imaging services also in different hospitals, including medical colleges. In Kottayam Medical College also we have one. We are providing MRI and CT services at affordable rates when compared to the markets. And Amrit Free Generic Pharmacy is the HLL brand under the ministry for providing pharmaceutical products and implants at affordable rates for the population. So, as in a nutshell, this is the products which are being manufactured and marketed by HLL. These are some of the brand names: Moods, Velvet, Emily, Saheli, Novex, Happy Days, etc. Let me come to be talk today the latex technology, where we are utilizing for our production of condoms since the 60s. Initially, we got the technology for manufacturing condoms from latex from a company called Okamoto in Japan. So we started as a factory for packing condoms, which was produced and imported from Japan. And later we started our own manufacturing using the technology. So the raw material which is used for latex, which is common to this part of the country. I don't want to speak anything about latex in Kanjirapalli or Kopalli, because we are all surrounded by the plants which produce latex. So it's a stable colloidal dispersion of natural rubber, which is cis-1,4 polyisoprene in an aqueous medium. So you might have seen, all of you might have seen, it's a white, yellowish white liquid, which is like milk. Like milk is a colloidal dispersion of fat in aqueous medium. This is isoprene molecules in aqueous medium. So where does this latex come from? All of you might have seen that this produced from a plant called rubber tree, which is called Hevia brasiliensis, which was initially bought from Brazil, and it's also called para rubber. It came to Kerala through Ceylon and to the tropical countries. So this plant, this is the juice of the plant, which is a weeping of the coming from the vessels, the lutoid vessels. So this is being tapped on a frequent intervals to get obtained from the tree as a aqueous colloidal solution, which is sticky in nature, which can be just having unique properties of elasticity. So this consists of small spherical particles surrounded by a protective shell of proteins. So this is having a different distribution of particle size, small size to big size, typically around 1 micrometer. And this way the size plays a very important role in its surface effects. And the structure, the chemical structure is shown here. This is the molecule isoprene, and this is joined together to form the rubber polyisoprene. So for comparison, 1 teaspoonful of natural latex, there is approximately 3 grams of rubber. So you know that the total weight is much more than that. The remaining weight is water. So at a particle diameter of 1 micrometer, this means that it contains approximately 6 × 10⁻12 particles of rubber in the spoonful of latex. So the total surface area of the particles is approximately 20 meters square. So you have this small volume is having a much bigger area. Smaller the size, the area will be more. So if it is stretched lengthwise, it would stretch over 6,000 kilometers. That is the length of the chain. So how would a latex particle look like? It's a spherical shape, as I told. It is having a covering of protein over the each particle. The particle in the particles inside of the particle contains the polyisoprene molecules, and there are other materials called phospholipids, and which helps the molecule to have its shape, stability, and this is having a charge of negative charge, and this is being protected in the particles, and this is stabilized by the electrostatic repulsion of these particles. So what is the structure telling us? The high molecular weight means that the chains in the small area will entangle as a network structure. Like you can see the noodle, the pasta noodles, which is forming a chain entanglement structure. So it gives a measure of elasticity to the molecule. As you might have seen that from your school days, these rubber bands which are being used is elastic. So it gives it is being given the elasticity by a process called vulcanization, which is the chains are giving is cross-linked by using some molecules, especially sulfur. So when you use this latex, as I told, this contains rubber particles and much of it is water. Why this latex need to be concentrated before use? When you use this latex as such for a product, it is quite uneconomical because it contains only 30-35% of rubber. The remaining 60+% is water and other particles, which includes proteins, carbohydrates, lipids, carotenoids, etc. So there are ways to concentrate this latex before we are using it for a particular material to be produced. These are the steps or these are the methods which are being used for concentrating the latex, which we are not doing here in our household latex production. This is being sent to a collection center where the material is converted into a product. So these methods are, one is centrifuging. You are all familiar with centrifuging. When you are rotating the liquid in a higher speed, the solid particles will settle. And this can be used to separate the water from the molecules, isoprene molecules. Next one is creaming. Creaming is that also you have seen in your household activities when you cream then for producing the cake and all that. The cream contains the material, the hydrocolor material or the original material which we want. The remaining things will be settled out. So again, creaming also can separate the rubber from the water. Evaporation and electrodecantation are also two other methods which are being used for specialty products, which is not being regularly used, or is it not economically viable? So centrifuging is the main thing. So when you are centrifuging, as I said, the water is being separated and the latex is concentrated to the maximum percentage of 60% by this process. So remaining 40% will be water. So other than that, separation, the concentration will be, concentration will be much difficult. So this concentrated latex is being used for making products which are being used for making from latex alone. So centrifuging separates the water, separates the rubber, 60% of rubber, and the remaining 4 to 5% of dry rubber is going along with the centrifugate or the remaining solution of serum or the senex, which is called senex. It contains 4 to 5% of latex. So when you are using this latex, as I told, this is having negatively charged particle over the particle surface. So in order to keep it, we have to preserve it for a long time for the centrifugation process and before it is getting used. So for this, we are using a preservative. The commonly used preservative in the in commercial industry is ammonia. So we have ammonia solution or ammonia gas is being pumped into latex. It is providing the ammonium ions, keeping the latex from separate from each other and is preventing it from getting coagulated. So there are two types of ammonia latex which is provided in the commercial sector. It is a low ammonia latex and a high ammonia latex. Why this is being used is that when you're requiring a higher, longer time of concentration, keeping it for production, you need high ammonia latex. Whereas we are making for small duration of time or for small products, we require only low ammonia latex. Why you use our lesser ammonia? Because as ammonia, it is caustic, it's harmful to our health if we are inhaling it continuously. So then you can see a cross section of the rubber particles here. Sorry. So when you centrifugate the bottom fraction, we can see the centrifuge latex, the concentrated latex, and above which the serum is there. Serum contains a low amount of hydrocarbons, and proteins are also present in between. And this is happening when centrifugation is done. So this separation of the settlement of rubber particles to the lower area, where it is tapped to for collection for usage from the bottom. This is being done using some high-speed centrifuging machines in centrifuging plant. Here, the nearby, you can see a centrifuging plant here. St. Mary's Tower is there, where they are centrifuging the field latex, which is being collected from the fields, brought to them, and they use the process of centrifugation for separating the latex from the water. So they keep it as centrifuge latex at 60% concentration. Next process is what I told is screening. This is a simple process which is being tried by normal household activities or small scale industries, whereas like rubber band or small products, which is being done using a creaming agent. This creaming agent normally it is used as the tamarind seed powder, which is being used to separate this latex from rubber from the water. So the cream layer, which rises to the top, which contains the major amount of latex, which is also around 60%, and this bottom level, the serum level, is again as a consider as a effluent which can be removed from the mixture. Here, they may not get a extremely concentrated 60% may not be obtained. They may obtain by 50 to 50% only, because this much concentration is required for products which is not so critical in the terms of rubber, like rubber band or figure coats or balloons, etc. Now, coagulation. When you see the product from latex, you see a solid material. You are not seeing a liquid material. So this rubber particles are coagulated for forming the dry rubber material. So it is, as I told, this protein membrane is covering the rubber particles. This membrane is negatively charged and repel. When you add acid, these negative charges get neutralized, and then lattice particles join together to collaborate. And by the action of bacteria also, this will happen. So when you keep the rubber for a long time, normally it will get coagulated without adding of any acid. So when you see the schematics for the coagulation of natural rubber, the membrane is protein membrane is surrounding the particles. Inside the particles, you have the rubber molecules. So negative charge is there. When it come each other, it will not adhere or coalesce. So when it is when the acid is added or positive charges are there, this will neutralize the charges, and then the breakage of the molecules, and then it will coagulate. Particles will rupture and will join together. The membrane will rupture and join together. So thus the coagulation occurs. Either acid or bacteria can do this. So when you see the neutralized rubber particles, these ions are being positive ions are there, which will neutralize the negative charge. It will break the chain, the broken chain, and the particles will collide, and this will form an entangled structure, which is the rubber hydrocarbon. And this will be a stage called a pre-vulcanized stage, or it's a coagulated stage. So in the rubber mesh, you have seen water is there, rubber hydrocarbons is there. There are other materials which are also being responsible to give the stability to the latex. As I told, the latex is a colloidal material. It is a colloid particles in the dispersed in the water medium. So these colloids are being getting stabilized without being coagulated or being destabilized by the effect of other materials like proteins, carbohydrates, lipids, and enzymes, which are having specific importance of giving properties to this latex. This supports bacterial growth, increase volatile fatty acids, decrease latex stability, and some are acting as pillars. Some are acting as components for increasing its modulus, increasing its strength. So all these properties are being given by these additional non-rubber components. So why can't we use this rubber as such? We are getting it from tree or after getting it from the concentration. As you all know, when you are seen uncrosslink rubber or rubber which is obtained from the tree which is being coagulated, you see it will have elasticity, but it's not so stable. It will rupture, or it is not stable at high temperature. It will melt. So in order to improve the properties, latex is subjected to, or rubber is subjected to a process called vulcanization. Vulcanization, you all of us studied this in your school classes. It is the addition of sulfur. It is a name come from the Vulcan, the god of fire. And this is used to give linking between the cross links of hydrocarbons, which I have shown just now. So these hydrocarbons, which are entangled in the rubber molecules, is cross-linked, held each other with the help of sulfur atoms. So this is a process called vulcanization, and it makes the rubber more stiffer and more elastic. It will help to retain its elasticity. When you stretch a rubber band, you can see it is coming back to its state because of this strengthening effect. So it's vulcanized rubber. When you have a rubber which is gloves, you can stretch it, wear it in your hand, then it will retain its shape. So this is because of the elasticity is retained. So this is by the process of vulcanization. That's the importance of vulcanization in using rubber for its end use applications. So the process is happening by adding sulfur, heating it, whereby this rubber gets stiffer, stronger, and retains the extension or elasticity. It will reduce this tackiness. When you handle a rubber band, it is not sticking on your hand. But when you take latex on your hand, it sticks to your hand. You cannot. It's very difficult to remove it. But when crosslinks happens or vulcanization happens, the rubber gets stiffens. It is not at all having any tackiness. So what happens when vulcanization happens? When vulcanization is happening, as I told, the rubber, this is the carbon chain of the isopropyl molecules. In between the carbon chains, between carbon to carbon, there are sulfur linkages. There may be one sulfur, two sulfur, or n number of sulfur between the linkages. And depending upon the number of sulfurs or the nature of the crosslinks, this product will have different properties. So suppose we are using the rubber for making a rubber band. We want flexibility. We are using the rubber for making gloves. We want flexibility. When we are using it for making tire, we don't want much flexibility, but we require strength. We require abrasion resistance. We require hardness. All these properties can be adjusted by the nature of these forcings. So how these forcings are being formed? Is it by one sulfur or many sulfur? This determines the end use properties. So natural rubber is converted to a cross-link structure by the process of vulcanization. You can see why the vulcanization, what are things you are getting imparting onto the rubber. The rubber becomes hard, the rubber becomes more elastic, the rubber becomes more heat resistance, it is having higher melting point, and it resists oxidation. When you keep the rubber sheet in your home, those who have rubber in your home, when you keep rubber sheets, which is the dried rubber form in the home, it will get attacked by fungus or microorganisms in the long run. It will not be there stable for years. Maybe after months, it will get melted. It will have fungus attacks. Sheet പൂത്തു പോകുന്നു എന്നൊക്കെയുള്ള കേട്ടിട്ടുണ്ടാവും. So that's attached. So easily oxidation happens, it will break. It will not have the strength itself. So for imparting the strength, this process is being used in different industries. So as I told, the rubber is elasticity. It's a rubber, it's an elastomer. This can be treated by linking together. Elastomer can be made by linking together the polymer molecules to form a 3D network. In each directions, it will having a network. So the chemical bonds between the polymer molecules are called crossings. This is being formed by sulfur, and the sulfur can cause the natural rubber. This is the process of vulcanization. So in order to do the compounding of latex, we use several agents to impart the properties. We have to add sulfur to make the cross links between the sulfur carbon chains. So that we require sulfur. This is a major vulcanizing agent which is used for natural rubber latex. Natural rubber latex can also be vulcanized without sulfur. They can be vulcanized by other process called radiation, other process called peroxide vulcanization. There are also other methods. But the common commercially used method for imparting elasticity, nature, strengthening rubber is by sulfur as the vulcanizing agent. So when you use sulfur alone, this is going to happen in several days. When you mix sulfur and keep it in the vessel, it will take days to get the crossings. When you heat also, it will also take hours for the crossings to happen. So this is not commercially viable. So make it commercially viable, you want to speed it up. You have to cross-link it in minimum time, but obtaining maximum properties. For this purpose, what we do, we use some other chemicals which can accelerate this process. These chemicals are called accelerators. These are all chemicals which is being derived, which is having several functional groups, which are either sulfur donors or activators, which initiates the reaction of sulfur with the carbon. So, as I told, these rubber products which we are using may have to have a shelf life. When you use a gloves, it has to stay in the shelf for a year or two. When you use a rubber tire, it has to stay in the shelf and also with the car or bus for number of kilometers or years. So for this, it has to be have some the air resistant property or ozone resistant property, which is being imparted by adding other chemical agents called antioxidants. These antioxidants are scavengers which attack the radicals which are being produced in the environment by oxygen or ozone, and they themselves get attacked by this oxygen and keep the rubber intact. So these antioxidants help the rubber to be having the shelf life for the entire usage period. So we are using different pigments for the products, fillers. Then we are using some surface active agents to keep the activity of the colloids in a stable state. We are using viscosity modifiers in the latex for keeping the viscosity in the correct manner so as the product can be formed. And then we use other ingredients like waxes, oils, anti-foaming agents which should resist the foams, anti-webbing agents to prevent the webbing, and all such constituents. So these are the properties of the materials which you are adding: vulcanizing agents, which introduce the three-dimensional network; accelerators, which are able to support the rubber from oxidation, as for speeding up the reaction, and antioxidants prevent the oxidation. Fillers gives colors. Surface active agents will give the system to work much better in the latter stage. And viscosity modifiers are given to keeping the viscosity at a level which is being good for the product to be formed. So when we use this, when we take this latex from the centrifuging plant to a manufacturing site for a product for rubber, latex, or condom, or finger caps, or tissue expanders, or these baby tweets, anything, you want to have the optimum properties for the rubber for the product to be formed. So you are giving, there are, as I told, this is a polymer molecule having a particle size or variation of particle size, which is being in the latex, which is giving specific properties to the final product. Surface area will is meant that. So when it is kept in a ideal stage for a period of time, this is undergoing a step called maturation. Whereas what happened in the maturation is that this crosslinks will get affected. This will be adjusted. The monosulfuric linkages, the mono, bi, or polysulfuric linkages will get adjusted as we require for our products. The properties which our products require, we design that crosslinks so as to obtain the good properties for that. So in order to have the latex for such a process, we are keeping it for a maturation period. Normally it is for a few days. When these crosslinks are matured, when the surfactants and the soaps added are getting in equilibrium, and this will control the degree of vulcanization. That means the number of crosslinks between two carbon chains. This is the degree of vulcanization. That degree of vulcanization determines the final end properties. So this is being done by subjecting the rubber latex for a period of maybe hours or days for a process called maturation. So there are a lot of products which you might have come across your and from latex in your daily life. These are lip products, which includes gloves, industry gloves, contraceptives, feeding bottle tips, toy balloons. Foam latex products, the buds you use, the seats you stitch, latex extrusions, the latex threads which is being used in our garments, latex printing, which is a carpet backing, which is being used in the households, then coatings for paper, latex castings, certain toys and bulbs are being used, and rubberized coir products or separators, adhesives, pads, etc. are also being used. So, which are the process by which you make use of this latex for making your products, which I have already mentioned. There are different methods by which this can be converted to a product. For example, when you get a latex, a jar of latex, you want to convert it to a rubber band. How will you make it? You want to convert it into gloves. How will you make it? You want to convert it into a flower. How will you make it? You want to convert it into a bed. How will you make it? These are by different processes. So the product which we see, the KSRTC seats which you are sitting, or the beds you are laying, or the rubber bands you are using, these are all subjected to different process to converting this latex into that product. So one of the process is called dipping. It's a simple process, dipping of a mold into the latex, and which will form the shape of that mold, and which is getting dried in a oven for some time for the process of vulcanization, and then you can use it after taking from that. Simplest example is the gloves. A glove mold made of porcelain or glass, you can put it into a latex. When taken out, it form a layer of latex over the mold. Then you can dry it in the oven at a specific temperature for a specific time, which can be predetermined. Similarly, the seat cover, the bed cushion. This is being formed by a process called foaming. Like you are making the cake in your home, some foaming agent is added, and some stabilizer is added, some antioxidants are added. It is being subject to centrifugation. The forms will come out. This can be poured on a mold. Then the bubbles will come out. The foam material which is being come out. So it will form pores. It will form vessel channels, which will give a forming material. This is like how the forms are being formed. Then extrusion. The threads which are using in your garments, which are all elastic threads, which is being formed by the process of extrusion. The latex form mold, which is being pushed through a spinneret of small diameters of whichever you like. This is being put into the heating solution for getting cured. You will get a thread which is having strength, elasticity, which is being used in our product, in our garments. These are the examples. As I told, dipping. This is the most widely used process for the products of latex made of latex. This is the balloon and the gloves, which is the former, which is a porcelain former or a wood former or a glass former, which can be used, is inserted into the polymer, the latex concentrated latex, which is being mixed by the ingredients like sulfur, antioxidants, acids, accelerators, etc. And of course, color. These are also being given, and this is then withdrawn from the latex and kept for drying in the oven at a specific temperature, maybe 70 or 80 or 100 degrees Celsius, for a specific period of time, which will give a final product. And this can be taken, kept out from the mold by undowning. The stripping is happening. So when you dip, as I told, this is being dipping for the simple dipping for the making of balloons or gloves. There are different types of stripping depending upon the thickness you require or the type of material you require. For example, for baby teeth, you want pure rubber because your babies are putting in their mouth. So you don't want any other chemicals to be there. So you use the most pure form of latex, which is being not having any color or having a mild color, just having no other residual accelerators or residual antioxidants or residual chemicals, so as to prevent the baby from getting affected. So that is used. There is no other coagulant. I'll come to the first one. Straight dipping is the dipping of latex, dipping of the formers into latex, where to get a small thin film of material. For example, condoms or balloons, you require only thin films. So for that, you use only thin straight dipping. It can be single dipping or double dipping or triple dipping, depending upon your use. And second one is the coagulant dipping. This dipping is required when you require a higher thickness to the material. For example, you are making a industrial gloves. For example, the electricians use the gloves for protecting from the getting shocks. So these gloves are thickened gloves. So how will you make thickened gloves? Thickened gloves, by single dipping, you cannot go beyond a particular thickness. If you want to go beyond a thickness, you want to use a chemical which can deposit more latex into that mold. So a chemical which is having as I told, the latex is having negative charges. When you have put a positive material on the molds, this latex will adhere more into the molds. So when you require a thicker product, more latex, more rubber will come to the molds, and the more thicker the product will be. So thicker products can be made by the coagulant dipping. And heat sensitive dipping is being used for thicker products with a wall thickness of very high, like baby teeth, which require high thickness, so as it should not be broken by the babies when they bite. The simple dipping method is used for making condoms. Condoms are the contraceptive materials which are being used by male and female. Both are there. It's a barrier contraceptive which is used for preventing the given contraception and also to prevent sexually transmitted infections. So this is made by simple dipping, straight dipping process. This is being tested for production, freedom from pinholes, required bursting volume and bursting pressure, elasticity, strength, modulus, heat resistance, shelf life, etc. It can be made in different sizes, different shapes, different textures, different flavors, and also as we require. Second one, which is being using straight dipping, is the surgical gloves. So gloves are being produced from different polymers, not only from latex. There are people who are having allergy to latex, so they use latex-free gloves, which is being polyvinyl or nitrile or other polyurethane materials are used. So these are being different types are available. This is being used by latex by dipping these molds of porcelain. These are porcelain molds. Porcelain molds, which are being it is dipped in the latex for a particular time and then take out and then dried. Again, it is dipped in the latex so as to get the sufficient thickness for the material. This is another product which you come across in the hospitals, which is the urinary catheter, which is also known as Foley's catheter, which is indwelling catheter, which is used in when you are in a surgical situation or in a hospital stage. You cannot go out or you cannot urinate yourself. Then the doctors will insert this into your urinary bladder so as to drain the urine once it is formed without getting affected, without the patient going out for urination. So this is being used for a couple of days or weeks for as long as the patient is in the bed. Similarly, this is the Foley's catheter. It is having a balloon This portion is inserted into the urine bladder, whereas this balloon will ensure that the urine is being drained off outside. So these are called indwelling catheters. And then external catheters are there. These are called condom catheters, which is worn over by the male patients, and they wherever patients are bedridden and there are old patients who cannot go outside, frequently without any help to the urinals, and they use this material. These are all intermittent catheters, short catheters which can be used by the patients. This is the latex balloon manufacturing facility. This is the dipping tank. You can see different latex, different colored latex is being filled in the different channels, and the molds are being running into the channels. And this is dipped here, and then taken out, going into the ovens, get dried, and then stripped off by using manually or using other agents like water or slurries. Another product which you might have seen is the dental dams. Dental dams are a rubber sheet or a thin film which is being used by the dentist for while they are doing the surgical or the tooth extraction or tooth corrections, or separating the tooth from the saliva, and also keeping the patient also in good condition. And another thing is called the rubber rings which are being used by the dentist for fixing the rubber during the treatment of fixation of the teeth. Another product which is being latest is used is elastic bands. This is being used in a wide population outside the country, especially in the gyms and also in the personal training centers for giving strength trainings. As you can see, that lady is giving the strength to her leg by stretching these films. These are the baby tweets and baby nipples and toys which are being used for using latex. These are also in the West. It is being also used from without natural latex. They are using it from other synthetic material for using for people who are having a latex allergy. So these are after the dipping process. I said the next one is the forming. The forming of the latex is being done for making cushioned materials like the beds or pillows, which are being made from latex by using some forming agents which can generate the bubbles. They can escape the air, which can forms can be formed, and then a gelling agent for gelling the material, and then a curing agent to cure it in the oven. These are the examples, and these are the process by which they dip the formed the jelly agents which are being poured over through the molds, which are being taken out as a mold for a bed or a pillow. These are some cubes which are also being made for specific purposes. Some latex pillows and then latex adhesives. So latex can be used for making adhesives for fixing of tiles, resins, and other areas where it is industrially required. Extrusion of latex, as I told, it is used in the thread formation, thread manufacturing. We have a big thread manufacturer in the world, which is in the Palakkad. They are exporting a lot of thread which is being made using natural rubber latex into the various fabric industries in and around the world. And there are other items also which is being using these threads with of different dimensions, which is being used in different industrial activities. These are some these tapes which are, you may have seen the 3M tapes and all that, which is being adhesives and which is being used for insulating purpose. This is the threads which is being produced, cut into different sizes. This is a strand of thread which is being cut in different sizes. These are thimble threads which is coming through spindles which is being dried, vulcanized, and put into a roll size. This is used in different industries, as I mentioned. Latex tubing. when you go to a hospital, you might have seen there are a lot of tubes which is being used for the different purposes, include right from the tying of your hand, your IV fluids or other communication mechanisms in between the equipments. These are all usages of this rubber tubings. These tubings are either being used for vacuums in the vacuum apparatus in the hospitals or in the dental area, or for medical purposes in the hospitals. So this is normally latex is having a tackiness. When you use it in the body also there will be some tackiness. So sometimes it is being given a coating of some material which is like silicone rubber or other polymeric materials for giving a smoothness to prevent the tackiness of the material. So several other products are also being made from the latex. This includes beautiful flowers which are being made using latex. Then rubber stoppers, balls, different structures, teaching materials, etc. So in HLL, we have come across different products made of latex. As I told, the first one which we started is the main condoms, which was started in 66, which from a technology from Japan. And we are also into the manufacturing of female condoms, which is being technology developed by ourselves. And this is being procured by the international agencies as a female initiated contraceptive. We have a manufacturing facility in Kerala. And next thing is another specialty variety of condom, which is we having no smell of latex, high heat sensitivity, and higher strength, which is being used by, made by using incorporation of graphene into the latex. So another product which is being made, which was invented or innovated in our lab is the cervical spacer. This is a new device which is being used for the radiation attenuation purpose in the clinical radiation centers. It is used in a process called brachytherapy. There are two therapies where you give radiation to the body. One is teletherapy and one is brachytherapy. Teletherapy is you are aiming a radiation source to the body part from outside at a distance, so as to giving a radiation to the affected area, the cells to be destroyed. And brachytherapy is another therapy, same radiation which is given by going by permitting the source to go inside the body to go to the site and then destroy the cancerous cells there. So in this brachytherapy of cervical radiation, what have been done in the past is they are after planning they are using a applicator called pressure shoot applicator. Don't worry about the name. This is the applicator. It is a tube which is having two ovoids. One ovoid is here, one is in the other side, back side. So it's having a tube in between, going in between, which is inserted into the cervical area, and then is separated so as to enable the source to go inside, or the space has to provide. So this is the device. This is having two balloons at each side with independent exterior valves, which can be separately inflated by using air or water. So what is the use of this device? This device can, when it is inflated, this can separate the critical organs like urinary bladder or rectum away from the cervical area, so that the radiation fall on these critical organs can be minimized. This is being done in the past by using cotton gauze. Cotton gauze is soaked in water and being filled in the area to separate this, keep the oils intact and to separate the organs. But this is not happening as planned. So the organs also will get affected. The unaffected organs also will get affected by the radiation. So this was a project, or this was an idea, a requirement generated for the Regional Cancer Center Trivandrum, where the brachytherapy is being given. And we have, I can show you a video. I hope it will work. It's not. Oh, yes, go to the other way. Thank you. This is very good. This product has got international patents, and we have been awarded the National Innovation Award for this product from the Ministry of Chemicals and Fertilizers. Patients with the latex allergy cannot use this. That is not much prevalent in this part of the world. It is more prevalent to the Western population than latex allergy. This is a treatment aid. This is not as a, is a for a treatment. This is a treatment aid. So when you are using the brachytherapy, you are having, your patient is suffering from an issue of the radiation falling over the critical organs. So in order to keep the critical organs away, we are providing these balloons. This can be inflated, so it can go apart. So when you reduce the distance by 1 centimeter, your radiation fall is 4 times lesser than what you have in treatment. So inflated. Yeah, yeah. So you can see that. So this is a pictorial representation of what is happening, how it is getting used. So you can see the uterus, the rectum, and the bladder. So when you give the radiation to this cervical area using the applicator, these two organs will get affected. So the purpose is to keep the organs, critical organs, away from the affected area. So how can we do? So we designed these two balloons, which is joined together. In between the source can go, and these balloons can be inflated from outside using a source of air. So this will separate the bladder and the rectum away from the source. And once the treatment is over, then you can deflate the balloons, both the balloons, and then this can be taken out as along with the applicator. So clinically, it has been proved that we are able to reduce 25% of radiation fall on the bladder and rectum. This trial was done in PGH Chandigarh. I can show you one more. Can you show one more video? One more video. There. So I can show you the manufacturing of condoms also. So this is for those who are not seen a manufacturing facility where the latex product is being formed. This one? Yeah. What do you? Yeah. ഇല്ല പുള്ളിയും അത് പ്രൊജക്ടറിൽ കണക്ട് ചെയ്തിരിക്കുന്നത് Okay, sorry, there is no volume, so I have to explain this. This is our factory where we manufacture condoms. Hindustan HLL Lifewear Limited, formerly Hindustan Latex Limited. So we manufacture totally around 1.5 billion pieces of condom a year. So this is situated in Perurkada in Trivandrum, and we have more factories in Cochin and in Belgaum where we manufacture condoms for the requirement of government and also for the international agencies. We also have presence in the market, the open market also. So as I told, we are using natural rubber latex, which is centrifuged, 60% latex, which is being obtained from the different centrifuging factories and being pumped into the we are initially we are testing latex for the quality, whether this is having the required TS total solids, required viscosity, required DRC, required ammonia content, required zinc oxide content. All these contents will be measured so as to make our production process trouble free. So once it is confirmed that is having the meeting the qualities, this is being compounded using sulfur and other ingredients. Then it is vulcanized, it's pre-vulcanized and matured, and then got for the dipping process. Once the dipping is over, it is being formed into the mold as a thin film, and then it is passed through the anti-sticking solution, and it is stripped using a silica slurry, where it is taken to another place where it is kept in the oven for a high temperature around 80 degrees Celsius for a period of 1 hour or 45 minutes. And the molds are getting cleaned, washed, and then going for re-dipping in the dipping lines. So this is a rinsing, water washing, hot water washing, soap solution washing, and then it's going for the drying. Here that stripped condoms are dehydrated from the slurry, and then they are taken to the vulcanizing chamber or a washing machine dryer, where it is dried and then heated, and then it's tested for the quality parameters, the half product testing, whether it's having any issues, any production issues, and then the length and the dimensions are being measured, and then it is going for the electronic pinhole testing. 100% testing is done, and where this is being tested using electric current of specific voltage and ambient, and then this is being rolled into in a rolled condition, and this is being taken into the packing division where it is packed in a single using silicon oil as the lubricant in aluminum foil, and then this is being secondary packed in boxes, and it is going for the dispatch. And before this process, the 100% testing is happening, and the separation of the rejection condoms is happening. So it is ensured that no condoms is going outside with a pinhole. And this is the bursting pressure testing. This is a complete test for measuring the strength and the elasticity or the elongation of the condoms. So this has to pass the WHO standards, whereas it is having a specific elongation and a specific strength. This is also being measured in the quality control department. These are the different processes of handling the material for testing and for packing. This is the packing process. This single wallet packing is happening, whereas they are using silicon oil as the lubricant, which is going inside the sachets. And once it is filled, required volume is filled around 400 milligram is already filled. It is going into these sachets and going into the simple packing. And then this pack as per the schemes, as per the volumes, as per the requirements, this is being packed into the different boxes by the manual process. And there are different schemes for different countries, different schemes for different national planning programs, and different schemes for open market, different for the UNFPA procurement for different countries like Kenya, Tanzania, South Africa, Ethiopia, Brazil, Peru, and all. So we are the one of the major manufacturers of condom in the world, and we cater to around 45 different countries. Thank you. Okay, okay. So we shall take a break and then come back. Thank you.
Now we will have a tea break and we will resume the session at 3:20.
ഞാൻ പിന്നെ അത്തിക്കാൻ നോക്കി വണ്ടി എടുത്തപ്പോ ആ ഭാഗത്തൊക്കെ ഞാൻ ശരിക്കും തോന്നുന്നു വഴി ഓക്കെ
ലൈറ്റ് ഒന്നല്ലായിരുന്നു ഇവിടെ ആവശ്യമായിരുന്നു.
അല്ല എനിക്കൊന്ന് സ്ലൈഡ് ഷോ ഇട്ടാ മതി കറക്റ്റ്.
ആ ഇതല്ലാതെ
മറ്റേ മൈക്കില്ല അത് വരും. ആദ്യം ഉണ്ടായി. നീക്കാൻ തോന്നുന്നു സാറ് നീക്കി.
ഇല്ലാതില്ലേ അല്ലാതില്ലേ
All participants are requested to rejoin this.
കുഴപ്പമില്ല. സ്റ്റെപ്പ് നിൽക്കുന്ന സൂക്ഷിക്കുന്ന ചെറിയൊരു ക്രീക്നെസ്.
Welcome back. So we are speaking about the cervical spacer, which is being used for the as a treatment aid for brachytherapy radiation process. Another product which is being just developed by our R&D is a uterine balloon, which was also another product which is being which was developed based on a requirement from the clinical field. Earlier one was from the radiation field where the radiation activation was required. Here the issue was during the postpartum period, a lot of women faced with the heavy bleeding issues, which may be critical for their life. So in that case, what doctors do is they will try all the possible methods to arrest the bleeding from the capillaries in the uterine cavity. So while doing this, they may use how they have injections, they have suppositories, they have different drugs. But what all these much of these items are not effective in a short span of life during the postpartum hemorrhage time. In that case, they want a mechanical device or a mechanical device which can help them to arrest the bleeding of the uterine walls, thereby protecting the life of that woman. So this was developed based on a request from a doctor from Nanded, Maharashtra, where he was witnessing, he's a gynecologist, he was witnessing a lot of deaths in the rural area from the abnormal or postpartum hemorrhage. So we have developed again another balloon device, which is shown here. This is again having a two balloons in the longitudinal direction. This is the small balloon, this is the bigger balloon, and both of them have independent outfits where we can insert air independently to both the balloons and retract it whenever it is required. So it can withstand around 300 to 500 ml in the uterine area and 250 ml in the vaginal area for a minimum period of 24 hours. So the crucial hours is the initial period where the bleeding is heavy and they cannot control. And this was utilized in the rural area in Nanded, Maharashtra, and they saved a lot of lives of the poor people who were suffering from the postpartum hemorrhage. And this is currently under clinical trials, which will be over by in a period of 1 or 2 years, and then will be available in the market. This is yet another product made from latex. Again, from the requirement from the Palakkad area, not a poor patient, is a old patient an old patient whose son has called us and was complaining about he is attending his old bedridden, not completely bedridden, but partially bedridden father who is suffering from intermittent urination, urinary incontinence, and he's unable, he's managing with the diapers, adult diapers. Initially, it was okay. When time goes on, the number of diapers and the environmental damage or the issue of discarding it or disposing it become a headache to him and to the entire community. He once called to our CMD and then request, you are a public sector undertaking, manufacturing condoms and all that. Why can't you design a device which can help the old patients who is having incontinence, who is unable to go to the urinals and pass the urine, and especially in the nights. So this came to us as a social need. And we visited, we got the input from the son about his father, and we designed a balloon or a bag which can be attached to the swaddle area, which can engulf the genital organs, and urine can be collected whenever it is drained. It can be collected and it is passed. It is drained through the tube to the collection bags on the side of the bed. And the risk was, in order to keep this intact with the body, so we devised a tape which can fixed onto the on over the cover onto the body. And this is now used in continuation for last 1 year in Palakkad, this particular patient, and also other patients who are suffering from the urinary incontinence and partially bedridden. And the product is also a patented device and is now will be available in the market soon. Another requirement for a latex device came from the Defense DRDO, ETBGRI Chandigarh. So where they were depending on the imported materials for compressing their explosive materials, which is to be used in the warheads. And this is the mold facility which we use to dip the material. This is the actual device. This is the tank and the dipping machine used for the dipping this device. This is the mold, and this was a coagulant dipping. As I told, one coagulant was applied initially, and then it was dipped in latex multiple times, and then it was dried and vulcanized for the final product usage. And this is used for, this is a bag, a big bag. You can see the shape of when a man is standing near to this, a big bag which can fill the explosive materials inside and can subject to a high pressure and temperature for compressing it into a warhead. These warheads are being used in the big guns, artilleries. So these warheads are being compressed at high temperature and pressure. They want a non-conducting material which can adhere, which can resist the temperature and high pressure at around 100 atmospheres. So this technology was developed by us and transferred to the DRDO. So these are the products which are made by our HLL R&D, and we are also now into the development of new devices which are either latex or non-latex healthcare applications, which are meant for contraceptions primarily, and also for other treatment requirements. Coming to the use of artificial intelligence in the our area, this might be all knowing. You will be all knowing all to this technology is not a just single technology. It's a rather collection of techniques and approaches to allow computers to mimic the human intelligence. So we are hearing this is being used in the in and around the world for different applications. We are receiving all these WhatsApp messages and videos which are being made by the AI, which are all fake or maybe real. So this can be used in rubber technology also into different areas were to optimize the technologies to improve the product quality and to enhance the performance. So this is not really only automation of the manufacturing process, but also which can predict the maintenance or predict the requirements, predict the product properties, which is required for the usage which is mentioned for. So this can also understand the complex structures of the molds or predict the characteristics throughout the lifespan it is going to be suffered of exposed to. When in the initial stages where we are much of you may be knowing that latex is being collected from the rubber tree. So this is by the manual tapping process, which is a laborious or a human oriented business which is required on a daily basis near to the rubber tree. So there are motorized technologies, use of technologies for the tapping of machine on the rubber trees, whereby consistent cutting, safety of the tree, and also extraction of the maximum possible latex is enabled. These are the old versions which are being tried in different parts of the world, and this has been motorized or the robot activities. So by collecting cameras and intelligent systems for measuring the required force to be applied, angle to be taken, and the areas to be cut. These are all being measured using the different sensing mechanisms and according to the trees for different bark lengths, different angles of cut, and increasing the efficiency to around maximum, maybe say 80% above by using these robots. These are other applications of the AI robots in the tapping of trees. Apart from this, when the manufacturing is concerned, the process which is being used may not be the correct one or may not be the optimum one which is being required at this particular area. So this can be calculated based on the data given to the systems and data given to the techniques, and this can be use the different tools to reduce the development time, increase the efficiency and accuracy of the particular process. So when the rubber is concerned, the integration of biotechnology, whereas with the artificial intelligence to improve the microbial rubber modifications, whereas the growth factors like the biological factors like pH, temperature, other protein or other related things, all these things are carefully manipulated for the production methods. So in order to make it efficient and stable and adaptable and sustainable for the situations, this AI techniques can be used. So this AI coupled with the biotechnology areas, this can predict the required process or required conditions which are required for the better optimum results of the production. So AI can bridge the biotechnology and information technology for improving the bioprocess parameters. As I told, the pH, temperature, the biotic factors, all this are contributing to the bioprocess parameters, which is responsible for the yields of the rubber production, and which can be used for both the IT and biotechnology can be utilized in synchronous to enable the improvements in the production for the future activities. So as you may know that when you are considering a rubber and its properties, when you this is a graph which shows the properties which are required for the products with respect to the cross-linking density, which we have discussed in the first session. So there are different parameters which determines the end use properties. This include modulus. This includes the strength. This includes the hysteresis, the heat buildup. This compression set, which is being affected, which is being imparted on the final product. The hardness, all those things are being affected or being determined. Are determining the final end use properties of the product. product. So the AI utilization of AI-driven solutions can manipulate the formulations which is required for getting optimal results for this for the parameters. So in these are example of trial production where they are using the ANN structures, artificial neural network structures, like in our brain, we are capable of understanding the situations based on our previous experiences. For example, you have an experience of touching with the hot material, and then you pull your hand. So this is based on experience because you know that it will hurt you. So based on this type of experiences, this artificial neural network can predict the final properties or final effect on based on the inputs and the data gathered. This is being introduced or used in the trial analysis in the real world data of raw materials. So based on this after getting data using the AI, these properties of the rubber and tires can be predicted from the scanning information collected. What is the raw materials used in the compound? How it is going to finally affect your properties? What are the structural changes required? What are the modifications required? All those can be manipulated. Another thing which is being recently published is a tanglemer, the novel, word using this tanglemer. As I told, the three-dimensional network which is formed by the cross-linking structure. These tanglemers are apart from this cross-links, there are entanglements of the polymer chains in the polymer network, which is helping which is determining the final properties. These entanglements are called tanglemers, which resembles the noodles, I say, the noodles which is being having that structures, the pasta. And using this tanglemers technology, they are able to use a low intensity processing method, a lattice processing method that can preserve the long polymer chains. The polymer chains which is being given, the lattice polymer chains, the polymer chains is being preserved. The entanglements is preserved by the strength is being preserved by the entanglements or for tanglements. This type of work which we also have done in our group, which are being Professor Sony may be remembering that this is the double networks which were done at that time, 2004. So this was done basically by the double cross-linking networking. That is, initially we were cross-linking the polymers for a particular period of time and temperature, and while keeping it for a specific cross-linking for 70% or 50%, we take it out and keep it on extended stage. And then on an extended stage, we are giving additional crosslinks. In that case, these crosslinks, additional crosslinks will be formed over the existing crosslinks. These are the initial crosslinks which are being formed, partial crosslinks, and then it's extended to a particular length, and then additional crosslinks were given, and this will prevent the extensional crosslinks from getting disrupted and giving putting in the shape, and we give enhanced strength. And this is the concept of double networks, which was done at that time. So similarly, in the tanglemers, in regular natural rubber, this is the situation where the crosslinks are there, three-dimensional crosslinks are there, and this is the tanglemer shown. This is forming a entanglement against in between the crosslinks, which will prevent the further crack propagation. This is the crack which is given to the rubber membrane. And when this is not there, it is giving a crack like this. But when a tanglemer is there, it is preventing the crack from propagating. So this is another technology which is being now given in the evolving. Yes, exactly. Yeah. Physical cross density. Yeah. It was mentioned, but as I told, this is just now coming again. You see, this is the 2005 of 25 application. Yeah. Entanglements that there. they say a nomenclature is added. Tanglemus. So how things are being put in a different way. That is innovation, no? Seeing things, doing things in a different way. So an overview of proper processing based on the already available data or publications that this AI is supposed to transform the traditional industrial process altogether, and which will adopt the production management, quality assurance, and process control. Right now, people are using this in the logistics, where they are able to predict the requirements of this product at particular time or particular region or particular area, and this is been able to enable the data on the real-time monitoring and data-driven decisions have been taken. Sorry. So the fundamentals of AI in manufacturing is that machine learning languages are all known to all of you. Neural networks for pattern recognition, predictive analytics for maintenance and quality assurance, reinforcement learning for adaptive process control, robotics and automation. All these things are being learned at different levels, taught at different levels as part of the AI programming in the different different educational platforms. And all those going to benefit in the quality improvement, resource optimization, and productive maintenance. So coming to challenges which are being encountered in the reported literature, that it's on the data quality and availability, where this data is getting available for all these productive things, and the models which are being put are all complex and are infrastructure which is required for this compatible is not compatible, and there's a skill gap between the existing workforce and the new requirements. And there are also ethical concerns and on the cost and the scalability. So right now, several authors have mentioned there are found that there are a lot of applications in found in the optimized the manufacturing in rubber sector, and they are optimization of compounding, which is right now we are using a copycat of the textbooks. These are the compounding which is required for the products, but there are possibilities of optimization further in the formulation by doing the formulation adjustments based on the AI data. So intelligent shaping in automation of the defect detection based on the data on the defects which are detected in the past on the product. There are a lot of scope for the intelligent shaping. And predictive maintenance, how it is going to work in the fields or in the usage, there it can be manipulated, it can be attended. Then quality assurance, vision-based inspection systems. Like as I shown the tapping of the rubber using the robots, which can be data can be supplied by the cameras and the data of the thickness and length and height. So then other things are the digital twins for virtual simulations and supply chain optimization, which is being currently used by a lot of people in the sector. So future perspectives is which will be as are all dream things. AI-driven smart factories are will be in the future. Collaborative robotics, sustainable manufacturing with AI, as I just now said. Then human AI collaborations, the brain and the other artificial things are collaborating more. And AI enhance innovation and product design, as just we mentioned that the all things was innovated by seeing it differently. So as a conclusion, let me say that the integration of AI in rubber product manufacturing is going to be a game changer, because all the existing things are going to be changed, because the data driven is taken applied to the systems, which can generate a lot of new ideas, new forecast for the new areas and new behaviors. And by enhancing the machinery with AI, we can be more smarter, more efficient, and for the manufacturing processes. And it will enable predictive maintenance which is now being done after the issue is being detected, and this can the preventive maintenance can be done much more earlier based on the predictions by AI data. And it may be exciting to see how AI will continue to transform the industries in rubber manufacturing for the future based on the the updation of AI and the technology which is being coming out. And this is not being used in our sector now, but we are also trying to incorporate the essential AI techniques which can be used for our logistics and our preventive maintenance, and also our testing techniques which can take all the leads from the available techniques which are there. So thank you very much for the patient listening, and I am happy to hear your views on this and have some questions for any if any doubts are there. Thank you very much. Yeah, please. Yes, the mic is there. HL. Yes. Yes, we are doing it. I didn't say that we are doing that. No, I didn't mention that. Yeah, we are doing that. We are utilizing the nano fillers in the lattice combinations, whereby we can impart specific strength and other properties which are required for the betterment of the products. So nanocellulose of in a very minimum amount, which can be used for the nano reinforcement. We are not making nanocellulose ourselves. We are procuring from outside. It's from the vegetable origin only. Oh, thank you. Are you working on nanocellulose? Oh, good. Thank you. No, we are in our factory. We are not are in the use. We are only using in the logistics now. We are yet to start that. We have a separate team formed for that. Wherever possible, it is can be used. Of course, academic collaborations are also welcome for that. How we can incorporate AI techniques into the manufacturing formulation, especially in testing, because we are much of our revenues is being spent for the testing and also for the packing. So our product cost much lies on the testing and packing, not on the raw material or not on the production. So if whatever we can save in that will be a added advantage for our product promotion. Yeah. Yeah. Two type of maturations are given in our area. First maturation is maturation of the latex itself. So when the latex is mixed with the compounding ingredients, sulfur, accelerators, and all that, it starts interacting with the rubber molecules. So this will be starting is initiation of the vulcanization or pre-vulcanization. So we have to keep the latex in the liquid form itself for making our product. We cannot convert it in solid format or cannot permit it to coagulate. But during the vulcanization, during the maturation, the particles which are being there in the rubber molecules, they may coalesce, they may adhere together, and they may also having different type of conditions. So in order to make it in a uniform thing, where we have to, then once it is uniform, then the product quality will be uniform. Our film formation will be uniform. Our gelation will be uniform. So gelation is the formation of film. So film formation depends on the viscosity, total solids, temperature, speed of the mold, all those things. So once this film is uniform, the lattice is uniform, the formation of the film will be uniform with the uniform setting of parameters. If it is not uniform, some particles will be higher, some particles is smaller, then the film is not uniform. So then when we are exposing it to a temperature or a particular temperature or a speed of mold, then the formation of film will be different, thickness will be different, or the strength will be different. That will eventually end up in a failure of the product. So in order to make that the film better, the maturation has to be pakka. So whatever possible time we can give, that is better. But in the industry, we cannot wait for a longer time. So we will give for optimum time, maybe 5 days or 6 days maximum. We cannot give it for 10 days or 12 days. Then our production will be affected. Our value of the product value will, when cost will go up. Yes, 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 yes. Yes, there is no free movement of the molecules there. No, it's a dry rubber system. Here in latex system, it's a liquid system. So there will be molecules will be, the entanglements will be there, the movement will be there. And it is mixed and a small, cool temperature. It will be heated to a some temperature and then kept cold. So this is the time where pre-vulcanization happens. Pre-vulcanization is to ensure that better film formation and optimum film formation and good film formation. For dry rubber, it's not required. No questions means two things. You understood everything. Yes. Please be asking questions. Let it be a full question, no issue. The purpose of people like us coming here and speaking to you is that we need more entrepreneurs in our country. This is the region area. Startups are all there for you. The incubation centers are all there for you. You will be finding trying to find. I'm sorry. Yeah. Yeah. I will say a small example. I know a person who is named as what is his name? Oh, name his name Alex. Alex Cody, yeah, Cody. He is from Pala. He is a graduate in physics, a 60-year-old man. He used to, he's a rubber planter in a place near Pala. And he used to have a lot of ideas for his own. He asked questions himself. So whenever he see a rubber product, he asks why it is not this, why it is not that, why can't we make that way, why it is like this. So he come up with new ideas or new questions, and then finally he end up in solutions also. Maybe he will go to different people and discuss, ask them, and he find new products, newer products, which are not in the world. For example, there is a process called Vasti in Ayurveda, Vasti. So Vasti is done using a traditional. So he found a device which can do the Vasti easier. Because he went for a Vasti procedure in the hospital. Then he came to make that product. Because he thought about that. Similarly, he come with a rubber-based urine bag. Now you have seen only urine-based bags with plastic, PVC or other plastics. Rubber-based, latex-based urine bag. He has got one of the products I have seen condom, urinary condoms you see for a bedridden patients, urinary condoms. It is available in the market made by him also. So the basic thing I want to say is that he asked himself questions. Then what are things he see here is putting a question to his mind. I myself and Mr. Alex shared a platform in Trivandrum some 2 years back. I presented one of the product innovations. He immediately took a photograph and then asked what is it? And then I said, this is a thing. Then why can't it be like this? Then he went and he started making it. Not production, but trials. He doing trials and trials and trials. He made a menstrual cup made of latex. After trials and trials and trials. Everything he is trying. So that mindset is the main. Not any resources, not any education, not any
supports. He can be doing himself. His son is a mechanical engineer. He went to Australia. Finally, he called him back. Don't bother, come here and do it. And now he's looking up the business. He is making some of the products for the US market. He is not able to, he is not having education for that selling in US. So he is getting some help from a Goa person who is a NRI or something. So he is taking this product to US market. So what I'm saying is that you have a question in mind. You have what you see, then you have to say what if, how can we, what is not, why is it not like this? These things you have to ask. Then you will finally end up with a as an inventor, the innovator. That mindset, we all have that this thing of freedom of thought. We will do some degree here or engineering graduation or post graduation. We will go and work for someone. That is the same thing which we have been taught. Our parents have taught us. So things are changing. We have to innovate. We have to entrepreneur ourselves. We have to find out. This is the raw material which is available in this stage. We are the 75% producer of the national rubber products in India. Since we are not doing it, people are taking it from this place to Punjab to make rubber bladders, football bladders, and they are putting football back to Kerala. Everything is like that. We are not making it. There are other things which I saw a few of these. Similarly, there are other things which can be also be made with latex or rubber or other materials which are available in our vicinity. We are blessed with all agricultural things, our the climates, our resources, our. So you may not be a rubber technologist, you may not be a chemical engineer, you may something else, I don't know. But you can always think about what are other things possibility. People going simply going after this, they are going to Canada or Germany or England. Right. Because they are unable to get a job here in Kerala government or in the government because of this practice. They want to have a better life. And people going there, they are now thinking of coming back. These are my YouTube information. I don't know. They are really coming back. They are having there are a lot of YouTube videos. They are saying they are really coming back. So there is a scope for us to have in our motherland. That is the best one. Thank you. Thank you very much.
As we had came closer to the enlightening session of our FDP, it's time to take a moment to reflect and express our gratitude. For that, I welcome Dr. Mini Kuriakos, Associate Professor from St. Kitts College of Engineering, to do the same.
Good evening, all. I extend my heartfelt thanks to our esteemed resource person, Dr. A.B. Santosh Prem, for the insightful and inspiring talk on innovating for healthy generations. He has briefly explained about latex, its compounding stage, vulcanization, maturization, as well as various processing methods. A variety of healthcare products produced by HLL Lifecare Limited were also well explained. Sir, we are grateful for your time, wisdom, and the passion you brought to this session. Thank you.
Thank you.
I also thank Dr. Soni sir for organizing this FDP and all the other associated coordinators for coordinating this FDP very beautifully. Thank you.
Now, we would like to hand over a token of appreciation to Dr. A.B. Santosh Prem for this wonderful session. For that, I would like to invite Dr. Somi C. George, our FDP coordinator, to hand over to you.
Dr. A.B. is actually a junior part of Professor Sabu Thomas. We both from Professor South Thomas Lu as PhD student. Moreover, he got a prestigious 10 crores project fund from Bill and Melinda Gates Foundation. And that is for developing healthcare product. I think he is only 1% from Kerala. Maybe from India, I don't know. Maybe it's a every time they are calling short-term and long-term course. I also share it with our faculty members. But most often this is mostly aiming at healthcare products. Healthcare products. So we want that prestigious project. Please give a big applause. Thank you so much for coming over here and yeah. Thank you.
This Bill and Melinda Gates Foundation, I would say yes, one word. It's open to all. There is no question of qualification, no question of gender, no question of career. Open to all. So it's a grand challenge exploration for
Health changed the year, I think.
yeah, this last year, I think, or this year in January, one lady from Trishur.
She's associated with the
Some self-care, even have.
mostly like such kind of problems are there.
So, federal laws they are asking, they are
Human-based problems. Human-based problem they are. Actually, I'm being
this time is for
like okay, another
PMC.
sharing out the information. All everything sharing out. After successful, you will focus that. Focus that.
That scheme is called Grand Challenge Exploration. So in that you will get all the list of awardees. So you can see what are the things they have got on. And anybody can apply. Anybody means any
Even NGOs can
NGOs